are deep into a complex coding session and you hit a stubborn bug. Immediately, your focus shatters. First, you spot the issue inside your IDE. Then you tab over to a web browser to ask a large language model how to fix it. Finally, you copy the suggested command, switch to your terminal, paste it in, and hit enter. When that terminal spits out an unexpected error code, the cycle repeats. You highlight and scrape that text, tab back over to your browser, paste the exact error into chat, and start all over again. This friction exists because the traditional command line is isolated from your modern workflow. It operates as a passive, text-only interface, with no awareness of the context you have built up inside your browser. As long as the terminal remains a closed-off vacuum, you will constantly lose time bouncing between windows instead of writing code. OpenAI recognized this bottleneck, which is why they sponsored a project called Warp. Warp is an agentic development environment designed to eliminate that window switching. While legacy terminal emulators often rely on decades-old C codebases, Warp uses a high-performance foundation written in Rust, leaning on modern libraries like Tokyo and Alacrity for speed. To make the terminal AI-compatible, developers introduced a block-based system that slices command outputs into modular units. Terminal history becomes structured data, where every block can be selected and fed directly to an AI model, maintaining its original formatting. Redesigning the interface changes how the terminal behaves. It acts as a structured database ready to host autonomous agents. Warp moves past the standard AI chat window to allow for autonomous execution directly within the command line itself. If you visit build.warp.dev, you can watch this autonomy happen in real time on a live tracking dashboard. This public tracker displays thousands of active AI instances, called Oz agents. At any given moment, you can watch these agents as they read through user-submitted bugs, triage the specific issues, and write technical specifications. These bots spin up web-compiled environments, implement code changes, and submit pull requests. But you aren't locked into the native bot. You can bring your own CLI agent, like Claude, Codex, or Gemini. The modern terminal is now an active workspace where AI agents and human engineers seamlessly collaborate in real time. But bringing these agentic OpenAI models directly into your core development loop comes with a very real and unavoidable cost. To power these features, Warp requires telemetry and continuous data exchange with remote servers. The models need access to your inputs and terminal outputs to function. Because it relies on cloud infrastructure to process that context, this tool cannot be used in air-gapped networks where source code is forbidden from leaving the local machine. The technical footprint is also significant. Building this UI-heavy terminal from source requires a substantial Rust toolchain and much longer compile times than traditional lightweight emulators. The choice comes down to the productivity of an AI-native workspace versus the data privacy of a traditional offline terminal. If you found this technical breakdown of Warp helpful, subscribe to the channel for more reviews of bleeding-edge open-source tools.